Right, guys, we'll continue with our solution of systems of equation. Like we recall that we have done Gauss elimination. I think Gauss, something like this, Gauss elimination. We also looked at that method which we called, it's referred to as Gauss-Jordan. Gauss-Jordan. And I think we also looked at Cramer's rule. Is that right? Cramer's rule. Now, at this moment, I want to introduce to you a method of solving equations using the inverse. Let's say A is a matrix of coefficients, then you can use the inverse to solve the equation. Let's say you have been able to reduce this system to A, x equals to B. Like I said before, this is exactly something like 2x equals to 8. Then here we said we could multiply this thing by 2 to the power minus 1 on both sides. 2 to the power minus 1, we get x equals to 2 to the power minus 1 times 2 to the power 3. And applying the rules of exponents there, what is that? 2 to 2, isn't it? Which is 4. That side. So we want to sort of follow a similar kind of approach, which is discussed here. This is what we do. I mean, this is what we've seen before. I mean, several times. So then we wish that if we take such kind of a matrix which could work like 2 to the power minus 1, as we said already, that matrix is called the inverse of A. So we multiply here by A inverse, pre-multiply this. When I'm putting I'm multiplying here by A here, I'm saying I'm pre-multiplying this by A. Then it will multiply exactly both sides by same A, pre-multiplying both sides in this case. Then here I will give x equals to, why is this thing doing this? This is equal sign, and then say A power minus 1 B. What I'll be having here, I'll be having the vector, the unknowns in the column matrix A, X, Y. Then that side, from this, you will see that this will give you a 3 by 1 matrix, which will be B1, B2, B3. And then those two matrices being equal, I think you can say, therefore here, X is equals to B1, and so on. What together, isn't it? Now if I give you a matrix like this one, so it means then you must reduce this matrix to this form, matricial representation. But be careful. I wrote this equation exactly in this way to call your attention to the fact that you don't just jump on the equation and then extract matrix of the equation blindly. Do you see that? The first example I gave you wasn't like this, because I was just trying to explain something for the first time. But now, you can get an equation like this. You can see the variables are not in order. Are you together? So before you can get to this thing, you must reorganize this system. So reorganizing this thing, we're going to get this thing as 2x plus 2. Hey man, what is happening? There's something wrong with my pen, I think. Plus 4z equals to 1. I hope, pardon me for this clumsiness here. 2x plus 2y. Can you get that clear? Okay. Then in the next line row is x plus what? Plus 2y plus what? plus 3z equals to 1 again. Then lastly, we've got x plus, sorry? Come again? 4y plus 5z plus equals to 2. Okay. Now let's choose this equation to matricial form. Reducing to this matricial form, we say matrix A is 2, 2, and 4. Do you agree on that row? This 1, what else? 2, 3, then 1, 4, 5. Then you've got x, y, z, our unknowns. And then you've got 1, 1, 2. You agree, my friends? Okay. Sorry if that disturbs you. I normally sometimes, by mistake or intentional, call my students my friends. Is that fine? So now, we've got now to come to this process here. We've got to come to what we discussed here. We've got to move in this direction until we get to the solution. Now, what do we need now? We need to get the inverse of A. You're having that matrix in that hand, eh? Okay. A. Give me A now, only A. 2, 2, 4, sorry, 1. Yes. 2, 3, 1, 4, 5. Right. We said for a matrix to have an inverse, what should happen? We said there's a condition we must check first. What is that? The determinant of A must not be equal to 0. Now, I taught you cofactors and minors, isn't it? Now, today I'm going to use this exercise also to introduce another way of calculating a determinant using cofactors. This is what we're going to do. Listen, when you're using cofactors, you can either move along a row or move along a column. It doesn't matter which, you get determinant. So I'm going only to work with one column here. Then I want to invite you to go and work with one column, another row, a different one, and see that you get the same thing, which I'm saying. Is that right? So let's talk about cofactor 1, 1. We're dropping row 1 and dropping column 1. So there, this is what we do. Check what we do. We take the cofactor must have that 1 plus 1. Determinant of, what is the minor then? Is it the minor 2, 3, 4, 5? Correct me if I'm wrong. Is that right? That's that. Then let's go cofactor 2, 1. I'm calling the column. I'm calling column. Then I do that minus 1 bracket 2 plus 1. The minor is what? 2, 4, 4, 5. Then I look for cofactor 3, 1. Then I have the 3 plus 1. Then what is inside there? 2, what? 2, 4. 2, 4, 2, 3. Let's get the answers here. This is 1 plus 1, power 2 is positive, isn't it? Determinant 10 minus 12. What's that? Minus 2, isn't it? Am I right? Then this is minus 1 power 3, negative. Determinant 10 minus 16. What's the answer? It's 10 minus 16. It's minus 6. But there's a negative sign there. What's that? 6. 6. Then here, this is going to be positive. Determinant here is what? 6 minus 8. What's that? Minus 2. Now, what is the determinant of A? Check that, what I'm doing now. The determinant of A is now going to be calculated this way. You go to the position of this minor. What is there in that position is 2. Then you come here and say 2 multiplied by the cofactor. Are you hearing what I'm saying? I'm saying 2 multiplied by the cofactor. Then plus, you go to this position 2, 1. You get the entry there is 1. Then you say 1 multiplied by the corresponding cofactor. Am I making myself clear? Is it crystal clear what you're supposed to do? If it's not, guys, please, you stop me. Is anybody confused? Okay. Plus, I want somebody to tell me from your group, just let's say one volunteer, tell me what to write. Just to show me that you have understood what I'm talking about. No, I said one person. If it's one person, you raise up your hand, then I pick on you. Not a chorus. Who is talking? Okay, my sister. 1 multiplied by minus 2. So they have used a different multiplication sign, but I hope you understand that it's the same thing there. If it has to be uniform, I think it's good to write it that way. Right. So now we simplify this. Here we're going to get minus 2. Here we're going to get minus 4, which is minus 2, that's 6. Is that 6? Then we've got a problem here. Are we together? Maybe we'll make something wrong somewhere, because I'm expecting this matrix to have a determinant which is different from 0. Well, it's giving us 0. Are we sure here this is, what's it? This is minus 6. Sorry? Come again? Talk, I'm not hearing what you're saying. This is supposed to be minus 6. Minus 6. I'm saying, if we get minus 2, is this minus 2? Minus 2, and then this is minus 4. Which one?
The last cofactor of 3, 1.
This one? I'm not sure. It's 8 minus 6. Just check that. It's 8. No. It's 6 minus 8, which is minus 2. What sign do you get here? A positive. Okay, so there is a mistake. Good. Can one person talk so I can hear what you're saying? I realize there's a mistake, but if you're talking things I don't understand, then I cannot follow what is going on. What are you saying? What's happening here? Come again? Is this right as 2 or minus 2? Okay. Yes. Come again? Sorry?
No, I don't want to.
Okay. Let's just double check this. This position, we got this and that, isn't it? Then we say minus 6 minus what? Minus 8, it's minus 2. This is 3 and the 1 is 4, isn't it? So it's positive, it's negative here. Then this one, let's double check this one. This is 2 and 4, 5. Then you get 10 minus 16, which is minus 6. And this is negative, and that is positive. Then this is what? This is 10 minus 12. Isn't it? Which is minus 2. And this is positive, is that. Now when you come to check the positions here, you've got 1, 1. And this is making 2, this is minus 6, and this is 6. And this gives us 0. Understand? It gives us 0. Then it says that the determinant is 0. Can you pause there? Calculate using another method. Maybe we made a mistake here. Let's calculate another. Okay, now that we've discovered the mistake, let's correct this. Let's correct that. This is 15 minus 6. Was it? 15 minus 16. Then what is that supposed to be? Positive 1, isn't it? So this is supposed to be positive 1. Okay. Minus 1 or positive 1. Guys, work out that thing, simple man, you tell me. Positive 1 here. Okay. So this is a positive 1. Is that alright? Then you've got minus 4 minus 4 is minus 2 minus 4, which is minus 6 minus plus 1, which is what? Minus, sorry? Come again? Listen. Can you talk? Can one person talk? Then I know what you're talking about. You want to talk as a crowd. I don't hear, but you still get stuck. What is the problem? I have to change what? 331 and? Okay, there. Okay, let's change that. Then what do we get here now? It's 9 minus 8, which is what? 1. Okay. Then what's the sign of that? Is it a 1 or what? It's 9 minus 8 is 1. What is the sign coming from here? So it's 1. Okay. So it's 1 again here. Ne? Okay, we've got a 1 here. Let me just cancel it and say 1 there. And then it's 1 here and the 1 there. What's that? 2, isn't it? That's 2. And this is minus 4. Minus 4 plus 2. What it gives us? Minus 2. That sounds like familiar. This, oh sorry, let me raise it. Otherwise people are going to get some confusion there. Let's clean this up and then get what? Minus 2. Determinant not equals to 0. That's fine. This is, guys, this is a long process. You must be very, very patient. Are we together? You must be very patient. This is a long process. Now, what we're going to do now, we are going to use these numbers. These numbers, we're going to need them. These ones. These numbers. We're going to need them. So we've already done part of the work. Yes? There's no C2 on the board. Yeah. C21. This is row, this is column. Yes? I don't know what you mean by cancelling. I don't cancel anything here. 2-1, let's say 2-1. Let me look at what is 2-1. This is this row suppressed and that column suppressed. We're left with, this is 3 actually. This is what we said is 3. 3, 4, 4, 5. Let's correct that because we didn't correct it. We corrected it there when we were working, but we didn't correct it there. This is what we said. This is 3. Are we right now? Okay. Please ask if there's something holding you back. Because if you move too far from where you've got a problem, then you're going to have a serious problem. So let's keep this. These things are still useful. Altogether, what did you do? We moved along a row. So let's move along a row again this way. And no, sorry, column this way and the column this way. Then we'll be finished. So let's start by saying C2, C1, 2. Where are we? We are there 3. Is that right? We are now looking only for the cofactors. We have the determinant. So what are these? Minus 1 to the power 1 plus 2, determinant of what? Can you tell me? I think it's 1, 3, and the 1, 5. Am I right? 1, 3, and the 1, 5. Please don't blindly accept what I'm saying. Check that it's right. It's right. So what's the answer then? Let's work it out immediately. It's 5 minus 3. That is 2, isn't it? And the sign is negative, minus 2. Then you come here to C 2, 2. Remember, we're moving along a column, isn't it? C 2, 2 minus 1 power 2 plus 2, determinant of what? The corners, isn't it? The corners of matrix, isn't it? Then you get 2, 4, 1, 5. I hope everyone understands what I mean by corners. I'm just meaning that once you are suppressing the center row, the center column and center row, then we're left with the corners, the extreme corners, right? Which gives us what? 10 minus 4, which is 6. The sign is positive, so that is 6. Then see what? 3, 2. Minus 1 to the power 3 plus 2. Brackets. I want the contribution from you now. Play. Tell us. The graph is written play. Tell us, what should I put in there? I was just trying to see what is there behind those dark glasses. There's something, but it looks like we don't see what's happening. Are you seeing what we're doing, my friend? So to give me what you're supposed to put there. Okay, somebody else? Yes? 2, 4, 1, 3. Are we sure? Yes, 2, 4, 1, 3. That's good. Okay? My friend, you see somebody in front of you, you can see it quickly. You don't see it. If you've got a problem, please talk. That's 6 minus 4. What's that? 6 minus 4. And then this is negative. So negative 2. Then let's come to the last column now. It's 1, 3, ne? Minus 1 to the power 1 plus 3, brackets. Who's going to tell me now? Who is going to tell me? Yes? 1, 2, and the 1, 4. The others must be checking whether it's doing it correct. Is it doing correct? Okay. And then 4 minus 2, which is 2. What is the sign? Positive. So we got a 2 here. Then C 2, 3. 2, 3. And then minus 1 to the power 2 plus 3. Determinant of what? 2 2, 3, 1, 4. My friend, are you going to go out of this class without mentioning in 1? Play. What is your name? Masejo. Are you going to go out without even mentioning it in 1? Let's reserve the last one for you. Because it's really, I want to see that everybody is at the same page. Here is the determinant is 8 minus 3, which is 5, isn't it? And what is the sign here? It's negative. So we will put there minus 5. Then we've got C 3, 3. This is for Masejo. Please keep quiet. This is for Masejo. Masejo, tell us. What's the determinant we're going to work with there? Guys, do you still want me to draw lines and pick lines like I did the first day? The first day I was doing this. 3, 3. I pick this line. I come and put it over here. I pick this line. I come and put it over here. And then say, what is left there? So Masheko is doing the first day today. I hope there are not too many Mashekos. By saying, I'm trying to say, I hope there are not too many people who are in the same situation, because that is the best. I really hope you do something, my friend. Because now, you didn't give it to me. I showed you. But I was hoping that you now understand the process of getting those minors. Mashek, sort out that problem, my friend, before it's too late. What is that? 4 minus 3 is 1. The sign positive. That is 1. Are we together? Now, listen to me. We're going to use all these numbers, the numbers we've calculated, these numbers. We're going to use them to create a new matrix. That matrix, call it the cofactor matrix. We're going to call that matrix the cofactor matrix. These numbers are going to make matrix called cofactor matrix. The row 1 will be C11, C12, C13. Row 2 will be C21, C22, C23. So these are actually rows for this new matrix. Though I moved with the columns in that matrix, but they are rows for the new matrix. Are you hearing what I'm saying? Okay. So now, let's put that matrix here. Let me put that matrix here. I'll give it a name C, and they call it, and say it's minus 2. Is it minus 2 minus 2? Minus 2 and the 2. Then it's 1, 6, and what? Minus 5. And it's 1, minus 2, and 1. That is called the cofactor matrix. So everybody now can say, to get an inverse, we first have got to verify that the determinant is not 0. We verified it there. It is. It's not 0. Then, using this method to find the inverse, you then find a cofactor matrix, and then the method is given using cofactor. Are we together, guys? Right. Now what I want you to hold on, can you hold on that cofactor matrix? I will ask for it now. Let's hold on that cofactor matrix. I'll ask it for now. We've got A first. What is A? 2, 3, 4. Isn't it? 2, 3, 4. Then 1, 2, 3. Then 1, 4, 5. That is A. Determinant of A equals minus 2, not equals to 0. Then cofactor matrix. Give me the cofactor matrix. You've got it down on your paper. Minus 2 minus 2 what? 2. Yes? 1, 6, minus 5. Then 1 minus 2 and 1. Right. Now, let's see. I hope I talked about this, but if I didn't talk about it, I'm sorry, I will introduce it now. And I think it's the right time to introduce it. We've got another matrix called C power T. But don't say C power T. Say C transpose. Read this thing as C transpose. What is C transpose? In simple language, if somebody asks me what is the transpose of a matrix, I'll tell him the transpose, the row of the matrix will become columns. Did you what I said? The row of the matrix will become columns. So now you come here, say C transpose, then we call this thing, we do this thing. Look at this. The row is this one. I said the row of the matrix will become columns. What is not going to change is the principal diagonal. I'm marking the rows. What am I going to do? This is the center of rotation, and the rotation is going to go this way. You are seeing what I'm going? So the center of rotation normally does not move, isn't it? So if I pull this thing down, rotating it, I'm going to remain with minus 2. Sorry, I want to pick my right ink. I'm going to remain there with minus 2. What's going to be here? Minus 2. What's going to be here? 2. Then the center of rotation is this one. Now if I rotate this in this direction, what's going to happen? What's going to be here? What's going to be here? 6. What's going to be here? Minus 5. Then when I come here, the center of rotation will be this one. Then I'm going to rotate this thing in that same direction. What's going to be here? 1. What's going to be there? What's going to be there? Are you sure? Is this a 1 or a 4? A 1. So I wrote it as a 4. Sorry for that. This is the 1. I think I was trying to type my 1 when I wrote it badly. This matrix, I call it transpose of the matrix of the cofactors. Is also called the adj of A, meaning the adjoint of A. How together, guys? Now, A inverse is always going to be 1 over the determinant multiplied by the adjoint of A. And then everybody now can tell me what is the inverse. What is it? I think it's minus 2 there, minus 2 there, sorry, 2 here, and then 1 there, 6, minus 5. What's that? 1. 1 minus 2 and 1. Homework. You're going to do this later. You must multiply A inverse, which is this one, multiplied by A, and check if you've got the identity 3. You must also do A multiplied by A inverse and see if you get the identity A. And that is expected, but just you must verify that. But because I believe that this is true, now what am I going to say? I'm going to say in that equation where I had A, X equals to B, I can now multiply by inverse here. And the pre-multiply by inverse on the right hand side. You see what I'm doing there? It's like a multiplying by 2 to the power minus 2 on both sides. On that equation, 2x equals to 8. I'm multiplying by 2 to the power minus 2 and multiplied by 2 to the power minus 3. Isn't it? We know here it's going to give us an identity, because what I'm saying there. So this is equivalent to, what's happening here? This is equivalent to identity multiplied by x, but identity multiplied by x is actually x, isn't it? Then that will be equals to A inverse multiplied by B. Are we together? So which means to get the solution of a system of equations which has been reduced to this form, this thing to do is to find the inverse and then pre-multiply the right hand side. Then you've got x. What is this x? This x is x, y, z, they are knowns in the system of equation. And then when you multiply that side, maybe let's multiply and see what we get here. Let's multiply. Let's multiply. What are we going to write there? We're going to write minus half. I'm talking about this minus half, isn't it? Then put the matrix minus 2, minus 2, 2, 1, 6, minus 5, 1, minus 2, 1. Then multiply there by, what was the right hand side matrix there in the equation? Look at the equation yourself. What was the right hand side? I think it was 1, 1, 2. Was it 1, 1, 2? Then 1, 1, 2. Okay guys, don't worry about this half here. Get busy, multiply there. Get busy, multiply there. I'm just waiting for you to give me answers there. Right guys, I'm not recording. I post that. Now let's go on. Now, I hope everybody's got this thing now. Let's check. We must have half minus half there. Then I think we are sure that we are going to get, this is a 3 by 3 matrix, this is a 3 by 1. And then this says we can multiply, I'm just reminding you. Then this says we're going to have this type of an answer, isn't it? So at the beginning they are going to have minus 2. I'll use a dot for multiplication, dot 1 plus 1 dot 1 plus 1 dot 2. Then I'll close my bracket there and then say what is this? Minus 2 dot what? 1 plus 6 dot 1 plus minus 2 in brackets dot 2. Then 2 dot 1 out together, guys, plus minus 5 in brackets dot what? 1 plus 1 dot 2. Then maybe let me put it this side. Then we've got minus half there. Then what do we have there? It's minus 2 plus 2, that's 0. We're left with a 1 there. Do you see that? This is 2, this is minus 2. That's 0. That's one left with a 1. So it's a 1 the first entry there. In this one, it's minus 4 and a minus 2, which is minus 6. Altogether, it's minus 4, minus 2, minus 6. There's 6 here, which means we've got a 0 there. Then here we've got minus 5 plus 4. Was a 2 and 2 is 4, and we've got a 1 there. Then it's minus 1. Okay, minus 1. Then you've got that. Then finally, you can say therefore. Therefore, x equals to half. Because now this minus half is going to multiply there. Actually, x equals to minus half. Y equals to 0. And then z, what is z equal to? Z equals to half. Now, to check the validity of this, let's take one equation and substitute this way and see whether the equation will balance, isn't it? So let's say checking. Remember, you're still going to multiply those identities that function in those matrices, matrix and inverse on the right and the pre-multiply, all those things. We're going to do that. Now let's check one question was 2x plus 2y or 3y, sorry. I don't know why my pen is writing so badly today. 3y plus what? Plus what? 4z equals 1. Let's substitute. This will be 2 multiplied by minus half plus 3 multiplied by 0 plus 4 multiplied by what? Half. That is what? That is the left hand side of the equation. All together. That's the left hand side of the equation. That's the left hand side of the equation. Let's see what it gives us. Here it's going to give us minus 1, isn't it? Minus 1, isn't it? Here it's going to give us 0. What about there? 2, isn't it? Plus 2. Then here we subtract. We get 1. And that is the right hand side. Altogether. But if you want, you can check with another equation. Okay, for the minimal now, can you check equation number 2? All of you. So not all of you. Half of the class check equation number 2. Half of the class check equation number 3. And then you confirm that is correct or not correct.